Good day, learners. You are welcome to today's lesson. Today we are going to look at heat transfer. All right. And last time we looked at conduction and the heat transfer. So today we will continue to look at convection. All right. So our lesson objectives are by the end of the lesson, you should be able to define convection as the transfer of heat from one place to another by the movement of liquid or gas particles. Explain that particles move upwards when they are heated. Explain that particles move downwards when they are cooled. And also define convection current as the movement of particles in a liquid or gas during heat transfer. And explain why heaters are best placed near the floor and air conditioners best placed near the ceiling. All right, so just some few concepts for terminology's sake. We have got heating, process in which energy is transferred from one hotter body to another. We have got temperature, which is simply a measure of how hot or cold something is. Then conduction, transfer of energy between solids that are in direct physical contact with each other. And then when we talk of conductor, they are materials that transfer energy easily. Then insulator are the opposite of conductors, meaning they are not able to transfer heat. Then when we look at variables are factors that are changed in an experiment in order to see the effect of the variable dependent on the results of the experiment in comparison to the one kept constant or controlled. Okay, now we look at convection, which is transfer of heat from one place to another by the movement of particles in liquid or gases. All right, so you might take a snapshot so that we will continue. So these are just some basic concepts related to this topic. All right, now let's go on to convection current. So convection current is the transfer of heat from one place to another by the movement of liquid or gas particle. So what it means is that convection occurs in liquids or they can occur in gases, but not in solids. Convection only occurs in liquids or gases which have got particles that move around easily. The particles of liquids and gases move more quickly when they are heated. When the particles move more quickly, they take up more space and the liquid or gas expands. The particles move upwards when they are heated. The particles move downwards when they are cold. So I guess you understand this. So mostly when you are boiling water inside the pot, that is basically what is happening. Convection current. The water underneath becomes warm, then they rise up, the cold water goes down, rise up. So the up and down motion in a cyclical manner is known as convection current, but we shall see it as we move on. Now let's look at the term convection current. So what is convection current? Is the upward movement of heated particles and the downward movement of cool particles in a liquid or gas which occur during heat transfer. Okay, now the heat is moved around in the liquid or gas by convection current. So you can see the heat is moved around in the liquid or gas by convection current. An example is heating water in a cooking pot. The water particles at the bottom of the pot will rise to the top of the pot. The cooler particles at the top of the pot will sink to the bottom of the pot. This continues in a cycle. So as you can see, we always use potassium permanganate to illustrate this. So you have the potassium permanganate under the beaker. Then you have warmer water moving up and then cooler water moving down. So this process is known as convection current. So when you use potassium permanganate, because it's purple in color, you are able to see the movement of the particles. The cooled, the warm air just close to where the source of heat is will rise up and just turn. And then the cold water goes down, the warm water goes up, the cold water comes down. So this movement is called what? Convection current, as illustrated there. Okay. Now, so let's look at what is happening there. Convection current, as we already had, is the transfer of heat from one place to another by the movement of liquid or gas particles. Convection can only occur in liquid or gases. It cannot occur in solids because the particles have a fixed structure and cannot move around easily like the particles in liquids and gases. So I repeat, convection can only occur in liquids and gases. It cannot occur in solids because the particles have what, a fixed structure and cannot move around easily like the particles in the liquids and gases. As particles are heated, they sink. As particles are heated, they gain kinetic energy and move around faster and become hotter. As the particles become hotter, they move upwards. The particles at the top then becomes cooler and sink down to the bottom of the beaker. The particles at the bottom of the beaker are then heated up. This continuous up and down movement of particles is called what? Convection current. So if ever you are told to use a diagram to explain convection current, you are able to do that. Convection current will continue until the liquid or gas is the same temperature. So meaning what is happening is that if the warm water moves up, the cold water comes down. So that process will be continuous until the temperature of the water is the same throughout or uniform. Okay, so now we will have to look at something here. And then basically, I want you to come back to me in the sense that I want you to answer this question so that if you are active here, I will know. So I want you first of all to differentiate. We've just looked at convection current, but I want you to differentiate between conduction and then convection as heat transfer. So if you are live and not sleeping, try to answer this question. What is the difference between convection current and conduction? Yes. Hello. Are you guys hearing me? I'm saying if I want to find out whether you are active, so please give me the difference between conduction and convection current, or convection and then conduction. So whichever way, there are two questions that you can decide. Give me the difference between conduction and convection before we can go. Yes. Kwapule, Junior, Mien, Moli, Tiana. Send me the, yeah, I want to see whether you are here. Yes. Okay. Please give me the difference. I want you to give me the difference between convection and conduction. Yes, I've posted something. Give me the difference between convection and conduction before we prepare. Guys, wake up, wake up, wake up. Wake up, wake up, wake up, wake up, wake up. I know you are still typing, but type very fast. Type very fast. Well, the difference between convection and conduction. Convection and conduction. I'm saying convection. Convection. Let me type again. Convection current. Convection and conduction. I want you to give the difference here. Convection and conduction. Convection, the difference between convection and conduction. Before we proceed, guys, are you available there? Convection and conduction. Okay. Yeah, perfect. But Molly, so it should be, yeah, instead of convection and conduction, but you just wrote that convection and radiation. So please, if you can change, check. But that's good. That's a good effort. Okay. How many kinds of substances can experience what convection? How many kinds of experience can undergo convection? Yes, how many liquids can undergo convection? Okay, how many types of liquid will solid undergo? Yep. How many types of substance? Guys, are you listening? How many kinds of substances can undergo convection? Yeah, this question as asked is just based on the what definition. Perfect, Angelina, you are there. Okay, so let's continue. Okay. And now we looked at, so can somebody explain convection current in his or her own words? You explain convection current using your own words. Then convection Okay, the question is explain convection current using your own words. Using your own words. Using your own words. Explain convection current using your own words. Using your own words. Convection current using your own words. All right. Yeah. Oh, sorry, I got it good. Okay, so this is what this is convection current. When you put a pot on the stove, then you start heating. The water molecules will gain the kinetic energy. Okay, what is going to happen is that the bottom part of it, the water will get heated, and when it gets heated, it will rise up. So, but on top of the water at the top is cold. Now, the warm water is less in density. It's not that heavy. But the cold water will be what heavy. So it will pick up the warm water and try to move up. And as it moves up, the cold water comes down. The warm water goes up, the cold water comes down. This process is known as what? Convection current. So I was basically saying try to explain it in your own words. Okay. All right, that's a nice try, Angelina. Okay, let's go to the next before we do this. All right. So this is just an explanation that I've given you before. So is as we said, convection is the transfer of heat from one place to another by the movement of liquid or gas particles. So, and it occurs only in liquids and gases. So as the particles are heated, they gain kinetic energy and move around faster and become hotter. So as the particles become hotter, they move up. So when they become hot, they have what less density. They are less dense, so they move up, and the water that is cold has got a higher density. So this weak one cannot carry the heavy one if I put it literally so that then the water will continue moving up and down. So when it's moving up and down, then we call it what? Convection current. Okay, now I have got this thing for you. I just want us to go through this so that those of you, before we go to Kahoot, those of you who cannot join us at Kahoot, at least you have got something to do with us, then we go and join Kahoot. So this is a question. Uh, what is convection current? Can convection occur in spoons? Can convection occur in liquids? All right. What is convection current? Can convection occur in spoon? Yeah, but we know that it can occur in liquids. Is the statement true or false? Convection is the transfer of heat from one place to another by the movement of particles in liquids, gases, and solids. What term do we give to the movement of particles in liquids and gases during heat transfer? All right, let's get going. 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 I hope you guys are still typing. Okay. 2A2. Question 2.1. So you are saying question 2.1 is saying, is the statement true? Can convection current or can convection transfer of heat? Convection is the transfer of heat from one place to another by the movement of particles in liquid, solid, and gases and solid. Are you sure? Double check your answer. Double check your answer. Double check your answer. Double check your answer. Double check your answer before we go to okay. Now let's quickly let me give you the correction so that we can go to. You can take a snapshot of this. So is the statement true or false? Convection current is the transfer of heat from one place to another by movement of solids, liquids, and gases. It doesn't. Okay, now let's go on. Is the movement of solid. Is the movement of particles and downward and upward movement. Okay. So all right, this is just a summary of which we have seen before. I want us to move to another topic, which is the assessment, but we are going to use Kahoot again. So this one is just for those of us who will not be able to join us in Kahoot. So let me quickly all right, I guess you can see. Can you guys see my slide? There is Kahoot here. Can you see my slide? Can you see my slide? Okay. All right. So if you can see, let's play. Can you see? Yeah, we are supposed to enter a game. Yes, you must enter again. Can you see the pin? Look at the pin. There is a pin. Yeah, look at it on your screen. That is, you go to www.kahoot.it, then you can sign in 24517, 24517, 24. So you enter this one, 24517 9. So that is your pin, 24517 9. So you join with that. Can you join? All right, great. That's nice. Lumo, that's great. All right. Uh, yes, I can see. So we are going to play now. So we are going to play now. You can see that the food is heating up. So now I'm listening. So let's place. So let's go. Let's get going. Plates are moved by convection, true or false. Okay, nobody got this one right. So let's go to the next. Okay. What is the definition of convection current? All right. The correct answer, matter, movement of matter from one place to another. Okay, so you got it right. Okay, now let's look at examples of conduction. Okay, perfect. We have got, let's look at the answers. The first person to answer it is Hele, followed by iPhone. Let's go to the next question. Which of the following defines convection? All right. So let's get going. Let's get going. Let's get going. So you have this thing is on the pot, and then you can see what we're talking about the convection. Okay. All right. So you let's see those who got it right. Oh no. Okay, let's go again. All right. What is an example of convection? Let's see. Let's see. You can see Junior, but the others are answering. So let's see those who answered. Let's see. Yeah, so you people answered it, but Livumo answered faster, followed by Angela. Let's go to the next. Convection can only transfer through air, true or false. Eh. Okay. All right. iPhone did well. You're the one who answered this one. Let's go to heat. So look at the following diagram. Yes, send in your answers. Your answers. Which of the following statements describe what most likely occurs when thermal energy is reserved or is reserved from a liquid? Okay, so let's see. One person got this one right. Okay, so let's go to heat energy also. All right, let's go. This one is still ticking. Yeah. Okay. Okay, there is one. This is the answer. Let's go and see. iPhone is correct. Let's go. All right, let's go to the next. What causes convection current? Yes, there is magical power. There is, okay, yeah. iPhone answered this first and is the only one who answered this. Let's go to 10 or 14. That's great. Let's, let's check. So the correct answer is one, the process by which it is also transmitted through a substance. Hmm, that's great. Let's go. Okay. I guess you people are seeing the scoreboard and who is leading us. All right, let's go to the next. Heat energy. All right, let's see. Many people got this one right. iPhone, Angela, and okay, let's go to the next. All right, that's conversion. Okay. Okay, very good. This one, many people answered it. All right, so let's see. Let's go to the next. Convection is when sure. Let's see how many people got this one right. Oh, only one. Let's see who you are the only one to get it and you have improved. Convection can occur through a solid. Okay, let's watch out. All right, let's see. Hopefully, and then Lurumo answered, but hopefully was the first. Convection produces what? Convection produces what? So let's see. Oh, the one, no one got it right. Okay. Okay, so let's see those who got high marks. This is the last one. So this question keeps on repeating. Okay. All right. Okay, so let's see those who did well. All right, now watch the one who did well. Third person, second person, and first person. Okay. All right, so let's go. So you see who is the overall winner here. Okay. So difficult question, you couldn't answer 14 of them. So let's get a feedback. Next time there is time, we will show feedback on the screen. Let's see. Okay, so this is the feedback. Learning outcomes. Okay. All right. Okay, guys. We've come to the end of the class. I have another class. Only you do not see anything. Others are answered. Okay, see you next week and then goodbye for now. Enjoy the rest of your lessons. Okay.